understand the notation and interpret the parameters of a normal distribution. So first, what is the normal distribution? Well, it's a continuous probability distribution. So it's really a way for us to talk about probability. All right, the properties. There are 4, and after we talk about them in words, I'm going to diagram them for you. So the graph is a bell-shaped. So you will often hear it's a bell curve, and it's symmetric about the mean, meaning the mean is in the middle, same on both sides, excuse me. The mean, median, and mode are all equal, right? Hence the equal signs there. So mean, median, mode, all the same. Half of the values are on the left and half of the values are on the right of the mean. That should make sense because of number 1 with the idea of being symmetric. Remember that symmetry, okay, so if we have a bell-shaped curve, symmetry is saying if we cut it down the middle, both sides are the same, half on each side. And the total area under the curve is 1 because, again, remember, we're talking about a probability distribution. And if you add all the probabilities of one thing together, they equal 1, right? Because 1 is 100%, which is all. Okay, let's look at this from a graphical standpoint. So here's our bell-shaped curve. So bell-shaped, and we talk about it being symmetric about the mean, which is about the center. So if I cut down the middle, pretend that's exactly in the middle, we would say this is symmetric and this is the mean. Now, by what we know from the last page, this is also the median and the mode, which should make sense, right? Mode is the most. Well, it's the highest bar, so that makes sense. Median is the number in the middle, so that makes sense. And then the mean, because half is over here and half is over here. Well, the mean is, there you go. Okay, so we've talked about, boom, 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 the total area under the curve. So also, half plus 1/2 equals 1. So if we're talking about, right, this would be 50% of the data, this would be 50% of the data, which equals 100%, which is 1. So all of the area under the curve is 1. Okay, now let's talk about this in terms of a couple of curves. So let's think about this solid line on the bottom as a number line, meaning numbers are smaller on this side and larger on this side. Okay, so what and how are A, B, and C related? Okay, so A, the graph far left, is the tallest graph, and you can see it has the steepest lines when it comes to going up and down. So here's the thing about what we know. It's the furthest to the left, right? Because we know if all of these are normal curves, that means the mean is in the middle. So this is the mean of A. For C, here's the middle, so that means this right here is the mean of C, and this is the middle, so right here is the mean of B. So in terms of numbers, A has the smallest mean. Again, if we're talking about the number line, smaller numbers are to the left, so A has the smallest mean, and B has the largest mean. Largest. Whew, almost couldn't spell right there. All right, so that's in terms of the mean. But the other thing I want to talk about is standard deviation. Okay, so standard deviation is the spread of data. So if something is spread out a lot, look at graph C, really spread out, that means this has a large standard deviation because standard deviation is the spread of data. So A, which is like not spread out at all, it's got those steepest lines, it's like really tall and skinny. So this would have the smallest standard deviation or a small standard deviation. So that's kind of how you can compare. They're really spread out. It's all about standard deviation, and where the mean exists on the number line can tell you how that value goes. So just a little bit of normal distributions, how the curves work, and how we can kind of talk between the different normal distribution curves. It also shows that not all normal distribution curves just look like this, right? That's kind of what we see a lot, but they can also look like this, because that can also be symmetric. They can also be really slow, right? Really spread out. It just depends on the mean and the standard deviation about how they look.